Yeah, because we can't open the windows.
Why can't you open any windows in the school?
Yeah, I know.
Crazy.
It's most buildings.
Isn't there a shop class in here?
Yeah,
The
right.
shop class fell over here for a day.
Midnight engineering.
Just got no more.
Yeah. All right, let me go through lab 5 because I want to make sure we get through this before we're done today, and then we'll come back and we'll talk more about memories. But lab 5 is building on all the stuff that we're talking about today and that we're going to be working with today and Thursday. So a whole bunch of parts to deal with, and there's some new parts in here. There's some capacitors. There's 1 mega ohm resistors. So the resistors we usually use are 1K. What's the color bands on a 1K resistor?
Brown, black, red.
Brown, black, red. Okay, so a 1 meg is going to be brown, black, green. And it's 1,000 times more resistance, so don't confuse those. Your LEDs won't turn on if you use a 1 meg. But we need 2 1 megs in this circuit. There's also capacitors. Capacitors are these tiny little, they're usually yellow-orange blobs with 2 wires coming out. And they don't have color codes on them to tell you what values they are. But in general, the physically smaller ones have a smaller capacitance. So you're going to find a really small yellow-orange blob with 2 wires coming out. That's probably your 0.01. And then you're going to find a bigger one. That's your 1 microfarad. This is going to be the one that's critical for what we're doing, the 1 microfarad. And you can ask me or anybody else who's around for help if you can't figure out which is which. And you're going to work with a chip called a 555. This is arguably the coolest chip ever manufactured. Okay, it was developed by an engineer who was on sabbatical and thought it would be cool to make a chip that could do what you could already do with 5 or 6 different chips. And he had this idea to build this chip, and he asked his boss about it, and his boss was like, no, that's a dumb idea. But he went ahead and did it anyway, and you can find pictures of him like developing it on a proto board, right? Getting this thing to work just right. And he went to somebody else in the company, and he was able to convince them to sponsor the production of this chip. And when this chip came out, I think it cost $1, and the going rate at the time for chips was $5. So that itself was remarkable. But the first few weeks after it came out, they could not keep them in stock. And the designer's phone, he said, kept ringing off the wall. And it was engineers calling him up, telling him all the different things they were doing with this chip. And it was things he'd never even dreamed of, right? So he designed the 555 to be a basic timing chip, something that will generate an output of 10, 10, 10, but in a way that's much more stable than those 3 inverters that we were looking at. And it wasn't new technology, it was just a single chip. It was a little 8-pin chip, and it's still, I believe, the best-selling chip of all time. It's just remarkable what you can do with this. So you can buy entire books of circuits that you can build with this. You can buy t-shirts with a picture of the chip on the front and some circuit diagrams. There's contests to come up with the coolest thing built out of this chip every year, and so on and so forth. And there's a lot of cool history behind the 555. All right, so your first experiment is going to be playing with a 555. So you've got these in your parts box. It's an 8-pin chip, so it's easy to find on that piece of foam. It's the small chip. 8 pins, the ground and power connections are different. Ground is pin 1, power is pin 8, so we're not on diagonals anymore. And we don't even use all 8 pins in our circuitry. All right, so there's your component ID chart up here. And this tells you that pin 1 goes to ground. That's the most important thing you can take away from this lecture. This will save you hours, because in this schematic, pin 1 is not shown connected to ground. And it doesn't happen to me anymore, but the first few times that I've taught this class, I'll spend like 45 minutes with someone trying to debug their circuit, because it looks like it's wired correctly and we can't figure out what's wrong. It's because pin 1 is not connected to ground. So make sure you connect pin 1 to ground. Okay, it says so up here, it doesn't say so down here. And then there's just this very peculiar wiring system. So you have two capacitors, RA and RB. Those are both 1 mega ohm, the ones with the green band. You have C, which is that 1 microfarad. It's a bigger orange blob. Okay, C goes here between pin 2 and ground. Pin 2 and 6 connect. 1 meg between 2 and 7. 1 meg between 7 and 8. Direct wire between 4 and 8. A small capacitor between 8 and ground. A 1K between 8 and 3, and then your output on pin 3. And pin 8 goes to 5 volts. If you wire your circuit up like this, your output will start toggling high and low, high and low. Okay, that's one of the functions of this chip, is to what they call an astable pulse generator. And how quickly it toggles is given by this pair of formulas. TH, that's how long the pulse is high. TL is how long it's low. And it's 0.693 times the sum of the resistances times the capacitance. Okay, so your resistors are about a meg. Your capacitor is about a microfarad. That's a million. Resistor is about a million ohms. If you multiply those out, you get 1 or 2. Multiplied by this magic constant, 0.693, which you'll see again and again in engineering. And so this will turn on for basically 1.5 seconds and turn off for about 3/4 of a second. It'll blink, right? Fast enough that you can tell it's definitely blinking. So your first goal is to build this circuit and stick an LED on the output, right? Connect the other end of the LED to ground through a 1K resistor, and you should see the LED blink.
So it's like a pseudo oscillator?
It is an oscillator, yeah.
Do we need an additional 1K resistor? Because it shows the 1K right there. You just need the LED.
So you don't actually need that 1K, but it's in the diagram, so go ahead and put it. But pin 3 from here goes into one end of an LED. Other end of the LED goes through a 1K resistor, and that goes to ground. So generally, any time that you hook up a LED, you're going to put a resistor in series with it. And this is not in series with the output. This is just pulling the output up to VCC. So yeah, you're going to have another 1K through your LED. But only if you're putting an LED on here. If you're hooking this up to an oscilloscope, you don't need an LED. And if you're hooking this up to other circuit, like you're feeding this into an inverter, don't put a resistor in. Okay, resistors are just used when you're driving an LED so you don't burn it out. Okay, so using these formulas, calculate how long this output pulse should be high and low, and then draw what you expect that output waveform to look like. So make a little sketch of it, show me how long it's high, how long it's low. Okay, and it should go between 5 volts and 0 if you set VCC to 5 volts. And then build this, and look at this on an oscilloscope, and see if it looks like what your drawing said. Okay, so compare it and explain reasons for any differences between the two waveforms. But hook it up to an LED first, because it's more fun to watch LEDs blink. But once it's blinking, put a scope on there, see what the actual waveform looks like. Okay, that's experiment 1. Experiment 2, you're going to make a bunch of blinking lights. And we're going to use a variety of parts here. So 74 LS138 and a 74 LS93. So the 138 is what we call a 3 to 8 decoder. And the 93 is a counter. And here's the idea. You've got your 555 from experiment 1. It's generating a pulse. Goes high, low, high, low. It's a train of 1s and 0s. Okay? This counter, we'll look at its data sheet in a minute, but it has an input that every time you change from a 0 to a 1, the output counts in binary. It'll start with all zeros. You raise the clock from 0 to 1, it'll go to 0, 0, 0, 1 on the output. You drop the clock, raise it again, it'll go to 0, 0, 1, 0, which is the number 2, and it'll count in binary. And the 74 138 is a decoder, so what does the decoder do? hope I started recording this.